geometry. Let's take a look here. 12 minus 5 is 7. Why can we drop the parentheses after we do with the?
Because there's no more like things to do in it.
That's right. So you have 3 times
Yeah,
21.
I did that wrong.
Okay, why don't you redo it from here?
Okay. $33.
So let's take a look here. New answer 33. 3 times 7 is 21. 8 times 4 is 32. Add them together and you get 33. Good. All right, so let's do, I got a bunch more here that we can sort of work on to get you more familiar with this. Let's try this one here. Go ahead and take a look at that and let me know what you come up with.
Okay. Let me double check this really quickly.
Sure.
Okay, 76.
All right, so we start inside parentheses there. 14 minus 12 is 2. We don't need the parentheses anymore. Now we can multiply. Exponents first, 64 plus 6 times 2 is 12, which is 76. Very good. Okay. Let's do another couple more here, and then we'll move on to a new topic here pretty quick.
$23.
23. Okay. Tell me what you did first here. What was the first math
So
operation that you did?
first I did the exponent. So I did 3 to the 3rd power,
Okay, what did you get for that?
27.
Yes, good.
And then I just set up the whole thing again. And then I did 6 times 3, which was 18. And then I did plus 4 times 8, which was 32 and then
Good.
minus 27. And then I did,
Excellent.
and then I added 18 plus 32, which was 50, minus 27.
Very good. Okay, you got it. All right, good or bad, this will be the last one, and then we'll move to solving some equations.
Okay,
Remind me, what grade are you going into next year?
8th.
8th grade, okay. All right.
Seven.
All right, let's take a look here. So 13 minus 8 is 5. 5 times 5 minus 3 times 7 plus 3. 5 times 5 is 25. 3 times 7 is 21. And you got 4 plus 3 is 7. Okay. All right, really good. So we've made it through kind of order of operations. It's an important thing to be able to do.
Mhm.
And I guess I'm going to take some time here to work on you with what is called solving one-step equations. And I
Okay.
don't know if maybe we've done this and you've got it down. We'll see here. Before we do that, though, I want to ask you some questions. These are things that you already know how to answer.
Okay.
So let's say I give you +4 and subtract 4. What does that become?
0.
0. So what that means is you undo addition with subtraction.
Okay.
And let's say it's negative. Let me change the number. Let's say it's -5 and you add 5 to it. What does that become?
0.
0. Okay. So you undo subtraction with addition.
Mhm.
So if you recall, when we were doing order of operations AS, the reason they could be done in either order is because they're actually the same. They're actually
Okay.
completely the same. So I'm going to write an equation here. X minus 3 equals 2.
Okay.
Okay. You look at the side with the variable.
Mhm.
What is this number? Tell me what's going on, what I'm circling.
3.
Okay, but what is this math operation?
Oh, what is it?
Yes, what
A
is the math operation?
subtraction?
Subtraction. So when you're solving here, the recipe is you look at the side with the variable.
Okay.
Okay. And then you said that it's subtraction by 3. So how do you undo subtraction?
Addition.
Addition. So you're going to add 3 to both sides of the equation. Now on the
Yep.
left, you have x minus 3 plus 3. Minus 3 plus 3 goes away. You could
Yes.
write this. Okay,
Yeah.
but what most students do is they just write x. Because
Equals
x
5.
plus 0
Yes. 5.
is just x. Okay.
Okay.
Have you seen this before?
Yeah.
Good. We'll maybe be able to get through this pretty quickly then.
Mhm.
All right. So the next thing here, let's try another one here. Let's go 6 equals x plus 2. So this time the variable's on the right. Okay. And
Yeah.
you always look at the side with the variable. There's the left side, there's the right side. Look at the side with the variable. And you say, you're really asking this question. What is keeping the variable from being by itself or alone?
Okay.
Okay. And the answer here is, well, you're adding 2. How do you
Uh-huh.
undo addition by 2?
Subtraction. Subtract
Subtract
2.
2.
And then put subtract 2 on the other side.
Right. So 4 equals x, but here's the thing. It's almost always the case that you want the variable to be on the left.
Yeah.
So you would write it this way, x equals 4. You'd want to
Yeah.
swap it at some point.
Mhm.
Okay, so if you think you understand that, I'm going to give you a couple of exercises to try. And
Okay.
just a moment here. I'm going to make these, I'm just going to throw the more difficult ones at you just to see where you're at.
Okay.
It's okay if you don't get them right, but just it'll help me to gauge where we're going from here. So
Okay.
here are 4 problems for you to try. Just give me your answers as you work them out, and
Okay.
let me know if you have any
Like one
questions.
by one.
Yeah, it just give them to me. I'll just write them down whenever you got it.
Okay. You want the first answer,
Whenever
or do you want to
whenever you're
wait till
ready.
I'm done with all of them?
Totally up to you.
Okay, I'll just wait and I'll just do all of them.
Okay, sounds good.
Okay, I'm done.
Give me your
So for the
answers.
first one I got was V equals 18.
Okay, keep going.
And then the second one I got was P equals 5.
Okay, good.
Then the third one I got was B equals 8.
Okay, last one.
And then for the last one I got N equals 6.
All right, all correct. Really good. That's fantastic. That's the right way to do these. So check something here. All right, so yeah. We're gonna come back to those, but that's really good. That's really, really good. Did I not give you? Okay. Let me, there's a few more that I guess I need to just make sure that you're solid on here. How about something, and you don't have to do it, just tell me what to do on this. How do you solve this one?
Okay, so what I do is first, I would do +9 to get rid of it, and
Good.
then I would +9 on the other side, and I would drop the M, put equals, and then I would do 13 minus 9.
Okay, I mean, it is negative
Which
13 plus 9, but yeah, I mean, you do end up,
yeah,
maybe you're talking
yeah.
about the sign thing, but yeah, go ahead and give me your final answer on that.
-4.
-4, good. Okay. So those are the first 2 types of problems you'll see. The next couple of types are, and we're going to go back here. If I have 5 and I divide it by 5, I get 1.
Mhm.
If I have 8 and divided by 8, I get 1.
Mhm.
If I have 1/3 and I multiply by 3, that is also 1.
Okay.
Okay, and if I take, for example, 1/5 and multiply by 5, that is also 1. And
Mhm.
this is again kind of like addition subtraction. You undo multiplication with division, you undo division with multiplication.
Okay.
And so in truth, multiplication and division are actually exactly the same.
Yeah.
Actually, they're like flips of each other. Same with addition and subtraction. So
Yeah.
why does that matter? Well, let's look at some problems here. Let's say I want you to solve 3x equals 21. So you go to the side with the variable. You go to the side with the variable, which is this right here.
Yeah.
And you'd say, well, what is keeping x from being by itself? What's this 3?
Yes.
But notice that they're just squeezed. I say squeezed together. They're touching. They're right next to each other.
Mhm.
That's multiplication.
Yeah.
You will sometimes see like 3 dot x equals 21, but you have to be comfortable with the idea that that is multiplication. So how do you undo multiplication? With division.
Okay.
You divide both sides. Now you divide using a fraction bar.
Okay.
You do not write the division
The
operator.
symbol. Yeah.
Yeah, you do the fraction bar here. So then on the left, 3 divided by 3 is 1x equals 7.
7. Mhm.
And what you don't need to do now is write 1, you can just write x. Okay.
Yes.
Because like
Okay.
what a lot of students do is they'll just come down to this line. They know that 3 divided by 3 is 1, and it would, and then you get x equals 7 or a number.
Mhm.
Okay. Now let's look at another one here. Let's say it's negative 5x equals 20.
Okay.
Even though there's a subtraction there, it's really negative 5 times x.
Mhm.
Okay. So you undo multiplication with division. So you divide both sides by the number in front of x. So you always divide by the number in front of x. What is the number in front of x?
20.
No. The number in front of x is negative 5.
Oh. Oh, okay. Wait, that looks like it's behind it.
You always, well, okay, so you always look to the side
At
with
the
the
number next
variable.
to it?
Yes.
Okay.
Like your focus has to be over here on the left. You're basically ignoring everything on the right.
Yeah.
So x equals, what is 20 divided by negative 5?
4. Negative.
Correct?
No. Yeah. Just
Negative
4.
4.
Just 4.
Negative 4.
Negative 4.
So
Wait,
quick
but
review.
isn't 20 bigger than 5?
Yes, but so when you're multiplying and dividing, here are the rules. And that's one of the reasons we do this, so we can figure this out. When you have two positives that you multiply together, the answer is positive. When you have
Okay.
two negatives that multiply together, the answer is positive.
Okay.
The same sign becomes positive.
Uh-huh.
Now, if you have a positive and a negative, that becomes negative. When you have a
Yeah.
negative and a positive, that becomes negative. So
Mhm.
opposite sign becomes negative,
Mhm.
like that. Any questions on that?
Nope.
Okay. Same thing applies to division. Positive divided by positive is positive.
Mhm.
Negative divided by negative is positive. So same thing, when it's same sign, it becomes positive.
Yep.
Okay, when it's opposite sign, if you have a negative over a positive, that becomes negative. Positive over a negative, that becomes negative. Okay, so
Mhm.
when it's opposite sign, it becomes negative,
Negative.
like that.
Mhm.
All right. So the other thing here is, and this is kind of what you're asking. Let's say it's like 10 divided by negative 2. It becomes negative 5 because
Mhm.
the
Opposite
negative really,
sides.
yeah, but the negative really comes up. Okay, so like
Mhm.
let me give you a different example. Let's say it's 3 over negative 9. The
Yeah.
negative really comes up, and 3 divided by 9 is 1/3. So the negative
Mhm.
always goes on the top.
Yeah.
Okay. All right, so let's give you let's have you try here a couple more questions before we close out. we'll have to pick up here on this, so. So go ahead and try these.
Okay. I forgot what to do with when the number's
Yeah.
right next to the variable.
Okay, so we're gonna pick this up here next time, but you would divide both sides by 8.
Oh, yeah.
So x
Okay.
equals, in this case, negative, uh, and negative 13, like that. But you and I can stop here. We'll let your sister jump on, and
Okay.
I'll see you next time.
Okay. Gloria. Hello.
Victoria, how are you today?
Good. How are you?
Good, good. Thank you for asking. I remember putting in the notes last time some problems for you to try. Did you get a chance to try any of those? If you did, do you have any questions? Anything of concern here?
No, I
Okay,
didn't. I'm so sorry.
that's okay. No, I'm just asking because I'm just trying to figure out where to start here. So we've been doing two things. We've been doing GCF and then LCM. Does that sound familiar to you?
Yep.
Okay, and all of this is based on being able to do a prime factorization,
Okay.
right? So do you remember from your notes the difference between a GCF and an LCM?
Yeah.
Could you attempt to explain that to me?
So for the GCF, it's like when you do the factor tree and then you see like if you do two, like what they have in common, like if they both had a 2 and both had a 3, it'd be like 2 times 3 would be 6. And then for LCM, you wait, let me think. Like I know how to do it, I just don't know how to explain it.
Yeah, and that's what I'm hearing. Like, yes, it sounds like you know how to do it. So let's take a couple of numbers here. Let's say 12 and 18. Yeah.
Okay.
So I want you to first give me the factorization of each of these,
Okay.
the prime factorization of each of these.
So okay, I got that.
Okay, so give
For
me
12,
the prime factorization for each.
for 12 would be 2 times 2 times 3.
Okay, and for
And for
18.
18, it'd be 2 times 3 times 3.
Okay, so the GCF, like you said, the GCF ends up being 2 times 3, which is 6.
Yep.
Okay, so here in words, here's what the GCF actually is, because this is what I was looking for. The GCF is the largest number that divides both numbers evenly.
Oh, yeah.
Okay, it's the largest number that goes into both.
Okay.
Okay. Um, any of those would be good. Any of those would be good. And so the GCF is always smaller than the numbers.
Okay.
It has to be. I mean, there's no way unless they're the same number, and you wouldn't do that. Now, let's do the LCM. What is the LCM?
36.
Okay, so how did you get that? It's 2 times 2 times 3 times 3, 36.
Yeah.
Okay, so the LCM now, let's talk about the LCM is the LCM is the smallest common multiple of the numbers. Okay,
Okay.
this is always larger than the two numbers. Like it has to be.
Yeah.
So this is the explanation I'm looking for. And it's good that you know how to do it. It's even better if you understand what it is that you're doing.
Okay. So tomorrow when I look over the recording, I'll write this down and I'll glue it in my note.
Sure. And you can go out to the internet and get another of these.
Okay.
All right. So let me, because I really want to get this down with you. So let me just, the hardest thing to do in math is to switch between topics, you know. So we're going to go
Yeah.
back and forth. I'm going to ask you for the GCF, then the LCM, the GCF, the LCM, or LCM, LCM, GCF, or maybe both. Give me just a moment here. I'll be right back.
Okay.
Right. I don't know why the this thing isn't loading, but let me take a look here. All right, so let me give you I'm sorry, let me also give you a problem here. I want you to find the GCF of 48 and 45.
Okay. So the GCF is 3, I think, if I did that right.
The GCF is 3, yes. So the that is good. Okay. All right, let's have you find the LCM
Okay.
of 15 and 18.
I got 90.
It is 90. Good, really good. Okay. So here's where we're going on some of this. So let's say I wanted you to add the fractions 1/2 plus 1/3.
Okay.
Okay.
Mm,
To do this, you have to first find the LCM of 2 and 3.
okay.
Now, this one's a pretty trivial example because you just end up multiplying them,
Yeah.
but it won't always be that way. So the LCM here is 6. Do you agree with that?
Yeah.
So we want to write this as a fraction over 6 plus a fraction over 6.
Okay.
So my question to you is what do you multiply 2 by to get to 6?
3. So
3.
the first one would be 3/6, and then the second would be 2/6.
Right. And now you can add the top because the bottom is the same and you get 5/6. Okay,
Yeah.
but now the thing is that's a pretty straightforward example. That's one where you probably already know what to do. But what if you're asked to do like 7/10 plus, actually, let's not do that. Let's do 9. 7/9 plus 5/6. Okay. Now you
Okay.
might have learned somewhere along the way to just multiply, multiply both of these by 9, multiply both of these on the left by 6. You really want to find the LCM of
Yeah.
6 and 9. So could you do that
Okay.
for us, please?
Yeah. So I got 18.
It is 18. Okay. So if you multiply 9 and 6, you get what's called a common multiple of 54, but you really want the least common multiple.
Okay.
Okay. And it makes your operations here a lot easier. So um tell me what goes in the top here and the top here.
Okay. So the first one would be 14,
Okay.
and then the second one would be 15.
Okay. Right. And
And
so
then
what
that
does
would
this
be
become?
29/18, which is an
20.
improper fraction. So then
Yeah,
you
now depending on the class you're in, this may
mhm,
not be okay. So do you remember how to convert this to a mixed number?
yeah. So
Will you
just
do that for me,
add,
please?
yeah, okay. So I got 1 and 11/18.
Good. Very good. Okay. Okay, so I'm gonna give you one to try on your own here. Let's go 7/36 plus 11/54.
Okay, so I don't know if this is right, but for the least common multiple, I got 108.
You are correct.
Okay, okay, just checking. I got 43 over 108.
Say that one more time. You got 43 over 108.
Yeah.
That is correct. Okay. So that's kind of the extreme example. Where you really use this is like, let's say I wanted you to add 1/3 plus 1/5 plus 7/12. Okay. So we need to find the LCM of 3, 5, and 12. So could you do that part for me, please?
Yep. Okay, I got 60.
What did you get for it?
60.
60. Yeah. So 60, 60, and 60. And you have to figure out, what do you multiply 3 by to get to 60? And that is 20, right? 3 times 20 gets you to 60. So you multiply the top number by 20. Okay.
Okay.
Then you ask yourself, what do you multiply by 5 by to get to 60? That's 12. Then you ask yourself, what do you multiply this 12 by to get to 60? That's 5. 7 times 5 is 35. And now you add the top. Okay, so 20 plus 12 plus 35 is 32 plus 35 is 67 over 60. And like you said, you can rewrite this as 1 and 7 over 60 as a mixed number.
Okay.
All right, is that okay?
Yes.
Great. So let me have you try one here. Let me have you try 2/5 plus 6. Sorry, let me do plus 11 15ths plus 4/3. And give me the LCM first. I don't want you to go much further in case there's an issue with that.
Okay. I got 15.
Yes, the LCM is 15. Good.
Okay.
All right, so go ahead and work it out from here, please.
So I got 6 over 15, 11 over 15, and 20 over 15.
Okay, keep going.
I got 37 over 15. Now I'll
Okay.
reduce it. And then turn to this number. I got 2 and 7/15.
Okay, very good. Doing great. Let's go for this here. Let's do another one. Let's go 3/4 plus 7 over 10 plus 3 over 20.
Okay, so I got 20 for like these common multiples.
Okay, I like it.
Okay. I got 32/20.
Right now, this is an interesting one because you can actually reduce the fraction. Remember, we spent some time talking about that
Mm-hmm.
earlier. So if you like the previous one didn't reduce, but you can reduce here. You can either do it right now, which is dividing the top and bottom by 2. That's
Okay.
16/10. And then doing it again, 8/5, which is 1 3/5. Or the other option here is you can go right from this 32/20 and write it as 1 12/20.
Yep.
But then you have to reduce this fraction here. You have to say, okay, I'm going to divide by 2, divide by 2, 6/10, divide by 2, divide by 2, 3/5.
Mm-hmm.
Okay.
Okay.
All right. So let's have you try another here. Let's go 7/8 plus 5/12 plus let's go 2/3.
Sorry about the vacuum in the background, by the
Oh, that's
way.
okay. I actually didn't hear anything. So
Oh, okay.
yeah, sometimes the microphones don't pick up everything we think they do.
Oh, okay. Okay, I got 24.
Okay, good. Keep going.
Okay, got 47/24.
Okay, and does that reduce?
Yeah. No.
No, it doesn't look like it. Can you
Yeah,
write
no.
it as a mixed number for me?
Yeah, sorry, I wrote my 7 and I thought it was a 4. So I was like, okay. I got 1 23/24.
Okay. So next time we're going to talk about subtracting. So just to kind of preview that here, could you tell me what 3 minus 5 is?
2.
It's actually -2.
-2. My bad. I'm so sorry.
Okay. Let's try another one here. How about -6 plus 7? What is that?
-1.
This is +1. So you
Positive
might want to
1.
review your sister's lesson on this just because we're going to need to be really solid on that. But go ahead and stop here.